Next question is of polynomials. It says if alpha and beta are the zeros of the polynomial 6x square minus 5x plus 1, then form a quadratic polynomial whose zeros are alpha square and beta square. This will be a 3-mark question. Now p of x is given to me as 6x square minus 5x plus 1. So roots of p of x are alpha and beta. So sum of roots will be alpha plus beta, which will be minus b by a. So that will be minus of minus pi upon 6. So that is pi upon 6, and product will be product of roots will be alpha beta, which will be equal to c by a. So that will be 1 by 6. Now moving ahead, quadratic polynomial whose zeros are alpha square and beta square, it will be x square minus sum of zeros into x plus product of zeros. So that will be x square minus alpha square plus beta square x plus alpha beta square. So alpha square beta square. So here I can make this equation as x square minus alpha plus beta whole square minus 2 alpha beta into x, because alpha plus beta whole square will be alpha square plus beta square plus 2 alpha beta plus alpha square beta square. Now next step will be I am putting the values, so this will be alpha plus beta is 5 by 6, so whole square minus 2 into 1 by 6 into x plus alpha beta, so 1 by 6 whole square. So this will give to me x square minus 25 upon 36 minus 2 ones are 2 threes are, so 1 upon 3 x plus 1 upon 36. So this will be x square minus, if I do LCM 36, so 25 minus 12 x plus 1 upon 36. So this will be x square minus 13x upon 36 plus 1 upon 36. So required equation will be 36x square minus 13x plus 1 equal to 0. Now next one is if alpha and beta are the zeros of the quadratic polynomial pi x square plus pi x plus 1, find the values of alpha square plus beta square and alpha raised to minus 1 plus beta raised to minus 1. So here p of x equal to pi x square plus pi x plus 1. So sum of zeros is alpha plus beta, which is equal to minus b by a. So that is minus 5 upon 5. So that is minus 1. Now product of zeros will be equal to alpha beta, which is equal to c by a. So which is 1 by 5. Now first one he has asked alpha square plus beta square. So that I can write as alpha plus beta whole square minus 2 alpha beta. So that will be minus 1 whole square minus 2 into 1 by 5. So that will be 1 minus 2 upon 5. So if I do LCM 5, so 5 minus 2. So it should be 3 upon 5. And the second one which he has asked is alpha raised to minus 1 plus beta raised to minus 1. So that I can write 1 upon alpha plus 1 upon beta. Now doing LCM alpha beta, so beta plus alpha. So again this will be minus 1 upon 1 by 5. So this will be minus 5. Now this is the required answer. Now next is the MCQ, which says a quadratic polynomial having zeros minus root of 5 by 2 and root 5 by 2 is x square minus 5 root 2x plus 1, b is 8x square minus 20, c is 15x square minus 6, d is x square minus 2 root 5x plus 1. So here alpha is given as minus root 5 upon 2 and beta is root 5 upon 2. So if I add alpha plus beta, so I will get minus root 5 by 2 plus root 5 by 2. So that will be 0 and alpha beta will be minus root of 5 by 2 into root 5 by 2. So that will be minus 5 upon 2. That will be 25 upon 4. So if I take root, it will be 5 by 2. So therefore, quadratic equation or quadratic polynomial will be x square minus 0x minus 5 upon 2. So if I multiply everything with 2, I will get 2x square minus 5 equal to 0. But here there is no such option given. So A1 and D1 are directly gone. Now if I want to make the 2x square is 8x square, I need to multiply the whole equation with 4. So if I multiply with 4, 4 into 2x square minus 5 will be equal to 8x square minus 20, which is equal to 0. So my B option is the correct option. Now, if you see the fourth question, it says the given linear polynomial y equal to f of x has two zeros, 1 0 and the 0 is 3, 1 0 and the 0 is 4 or no 0. So it is clearly visible that 0 is always counted when it is on the x-axis. So here if I see on the x-axis there is only one 0, that is 3 comma 0. So my option B is right, that is 1 0. And now the next question says the graph of a quadratic polynomial p of x passes through the points minus 6 comma 0, 0 comma minus 30, 4 comma minus 20 and 6 comma 0. The zero of the polynomial are minus 6 comma 0, 4 comma 6, minus 30 comma minus 20 and d is minus 6 comma 6. So we know that always the 0 is on the x-axis. So always x-axis value should be there and y-axis should be 0. So here only such two values are there, minus 6 comma 0 and 6 comma 0. So my required zeros will be minus 6 and 6. Now now the next question says, find the zeros of the quadratic polynomial x square plus 7x plus 10 and verify the relation between the zeros and the coefficient. So here we know that x square plus 7x plus 10 is equal to 0. So therefore I can say if I do splitting method, middle term splitting of 10, so I will get 5x plus 2x plus 10 equal to 0. So from the first two, I am taking x common, so x plus 5, and from the next two, I am taking 2 common, so x plus 5 equal to 0. So therefore, I got two solutions, x plus 5 and x plus 2 equal to 0. Therefore, x or alpha will be minus 5 and beta will be minus 2. Now, sum of zeros is minus 2 plus minus 5, that is minus 7, which is equal to minus b by a, and product of zeros is minus 2 into minus 5, so that is 10, which is equal to c by a. Hence the relation is. Here we know that a square minus b square is equal to a minus b into a plus b. So same way, if I do x square minus root 3 whole square, so that will be x minus root 3 and x plus root 3. So alpha will be equal to root 3 and beta will be equal to minus root 3. So sum of roots will be alpha plus beta, which is equal to root 3 plus minus root 3. So that is 0, which is equal to minus b by a, and product of roots product of roots will be alpha beta, that will be root 3 into minus root 3. So that will be minus 3, which is equal to c by a. Hence the relation between them is proved. Now the next question says, find a quadratic polynomial, the sum and product of whose zeros are minus 3 and 2 respectively. So sum equal to alpha plus beta, which is equal to minus 3 upon 1, which is equal to minus b by a, and product, which is equal to alpha beta, which is equal to 2, which is equal to c by a. So therefore a equal to 1, b equal to 3 and c equal to 2. So therefore required quadratic equation or quadratic polynomial is x square minus alpha plus beta x plus alpha beta equal to 0. If I put in place of x square, then minus of minus 3x plus alpha beta will be 2 equal to 0. So x square plus 3x plus 2 equal to 0 is the required equation. Now, ninth question says, Radha, an inspiring landscape designer, is tasked with creating a visually captivating pool design that incorporates a unique arrangement of fountains. The challenge entails arranging the fountains in such a way that when water is thrown upwards, it forms the shape of a parabola. The graph of one such parabola is shown to us. Now see, graph is shown. He is asking me some of the question. The height of each fountain not above water level is 10 centimeter. The equation of the downward facing parabola representing the water fountain is given by P of x equal to minus x square plus 5x minus 4. Based on the above information, answer the following question. First one is find the zero of the polynomial p of x from the graph. So first one, if I see the graph, I can clearly say that the zeros will be 1 and 4. Then second one, it says find the value of x with water attains maximum height. So see, water attains maximum height at x equal to 5 by 2. Then third one says if h is the maximum height attained by water stream from the water level of the pool, then find the value of h. So I can say a plus x equal to 5 by 2. So p of x will be 2.25. Therefore h equal to 0.10 plus 2.25, that is 2.35 meter. Now, in that, the B1 or B1 was at what point or points on the x-axis, the height of water above x-axis is 2 meter. So, minus x square plus 5x plus 4, sorry, minus 4 equal to 0 is the equation given to minus 4 equal to 2. 2 I want. So if I do x square minus 5x, this 2 I bring, so minus 6, so it will become plus 6 equal to 0. Now if I do the factors, I will get x square minus 2x minus 3x plus 6 equal to 0. I am splitting the middle term, so I will get x minus x if I take common, so x minus 2 and minus 3 if I take x minus 2 equal to 0. So x minus 2 and the other one is x minus 3 equal to 0. So either x will be 2 or x will be 3. So therefore, required points are 2, 0 and 3, 0.